Yeah, good morning, students. It's my pleasure to introduce this self-learning topic on the array operations. The important operation on arrays is that the search operation. So in the search operation, we have the basic search algorithm is the linear search algorithm, which is also known as a sequential search algorithm. So the self-learning topic is on sequential search or a linear search. Now I would like to share my screen. So hope my screen is visible to you. So the self-learning topic is on the array operations. Under that, the search is one of the most important operation that we have seen. Under this search, the search can be implemented in two different ways on arrays. One is a linear search or a sequential search. So in this particular self-learning topic, we would like to discuss about the linear search technique. Fine. So the objective of this particular self-learning topic is that this session will develop the students' knowledge on the linear search operation on array data structure. So what is this linear search? So the method of searching for a specific value in an array is known as searching. And there are two ways we can perform the search in an array. So one is call it as a linear search or a sequential search. And another one is call it as a second method is call it as a binary search. Fine. So for example, now we are going to discuss about this linear search method. So in this, for example, consider an array which consisting of these elements 10, 20, 30, 40 and 50. And we want to search for an element 30. Then how we can do in the linear search? So we will sequentially perform the search from the beginning. That is the 0th location. This, if you assume that this is an array A, so A of 0th location element is equal to this element 30. No. Then we will move for the next location. A of one location element is equal to 30. No. Then we are going for next index locations and we are searching whether the A of two location element is equal to the search element 30. Yes. Now we will say that element is found at index 2. Fine. So we will stop here and we will say that the element is found at index 2. Like that, this is what we are calling it as a linear search. So linear search is defined it as a sequential search algorithm that starts at one end and goes through each and every element of the array until the desired element is found, or otherwise the search continues till the end of the data set or till the end of the array. So like this, suppose if you are given these are the elements 10, 50, 30, 70, etc. 9 elements are there. Now if you want to find where this 20 is there, so we will start from 0th index. If it is not 20, then we will search in the first index, not 20, it is going for next index. So like this we are going to that. So once you reach to this 6th index location, the element 20 is found. So this is what we are calling it as a sequential search or the linear search. So it is the easiest search algorithm. Sequential search or linear search is the easiest method of searching. So in linear search is defined it as a sequential search that we have seen here. Fine. So the code for implementation of this linear search, if you see that, how do we implement that? So we are defining an array A of 100 elements and search is the element for which you want to search, and the C and N are, the C is the index and the N is the number of elements. So we are reading how many elements are there in the array into N. Then enter N number of integers. So we are reading by making use of this loop. We are reading the elements into this array. For C equal to 0, C less than N, C plus plus, scanf percentage D, ampersand A of C. So this is the loop for reading the elements into the array. Okay, array elements reading. So we are just reading the elements into the array. Then next we are taking that search element. Which element you want to search? Then we are taking for I equal C equal 0, C less than N, C plus plus. If A of C is equal to search, if the required element is found, then we are printing that element found at the location C plus 1. And then we are coming out of this loop by making use of the break statement. Fine. So if we reach to the end of the array, till that also we are not able to find the search element, that means if C is equal to N, then the element is not present in the array. So that we are displaying here. Fine. So now coming to this time complexity of this linear search. So time complexity of linear search is nothing but it is big O of N, as every element in the array has to be compared only once. And in linear search, the best case complexity is that it is big O of 1 where the element is found at the first index itself. Okay. And the worst case complexity of linear search is big O of n where the element is found at the last location or the element is not present in the array. So these are the best case and worst case time complexities for the linear search algorithm. So coming to this outcome of this particular self-learning topic is that after completion of this session, you will be able to develop the code to implement this linear search algorithm in an array of elements. Fine. So thank you. Thank you one and all.